Hey folks, my name is Vaibhavkejriwal and today we are going to be talking about how to build a RAG AI agent from scratch without knowing how to code on a platform called N8N. It's an AI automation platform. But before we do that, I want to talk about what is RAG and what we are going to be building today. So RAG is retrieval augmented generation. It is basically looking up data to answer a specific query or a question. And today what we are going to be doing is building it for a customer support representative team, and they can have this RAG agent on their backend to help support the queries. Now, before we do that, I want to talk about why we are doing this because that's the most important aspect of building anything or doing anything. So, what are the benefits if we use RAG with customer support reps? First is faster resolution time because they don't need to memorize things and they can just query it from the RAG bot and understand what the customer needs to answered. Right, it will reduce the costs from the support teams because you are now taking lesser time, so obviously the cost goes down. You're reducing the training time for the customer reps because they don't need to memorize anything. You're reducing the human error because again they are not speaking from their memory, they are speaking from this RAG system. And lastly, it's a very scalable way of managing your knowledge because you don't need your customer reps to learn every time there's a new product that is come up. You can just update the RAG bot and then they can just learn how to query it, which they have already done. Next, I want to talk about the RAG framework that we are going to be building, right? So let's take an example. Let's say we have a query, who is the author of this book? Now that's an information we don't have access to right now. So what will happen? We'll send it to retrieval QA chain, question answer chain. It will then use an LLM and rephrase the input and send it to vector database. It will get the answer from there. Again, use LLM to rephrase the output, and the retrieval question answer chain will return Mehul Gupta has authored this book. Now, you are thinking what is vector database? I'll be talking about it in a minute. I just want to talk about how we are storing information. So let's say we have a PDF which has all the answers. It will use the document loader and process the text and convert it to smaller chunks. So let's say PDF is 50 pages. We will break it up into small chunks and then use an embedding function to put it in the vector database. An embedding function is basically a way to numerize the data that we have, convert it into number format, and then store it in a vector DB. And that is the database that our RAG agent is going to be using to answer the queries. Okay. Just a quick view of how it's going to look like in N8N. We are going to query from here to the AI agent. It's going to use its brain, which is OpenAI, right? It's going to store or chat information in this memory, which is Postgres. I'm going to be talking about a bit later, but you can basically have a record of all the data that you have, all the charts that you have, and then it has a superbase vector store where it is querying the information from. I will now talk about a vector DB. So basically, it's a database where you store information basis on what they mean. So let's say we have history and geography, which are basically two subjects. So they are stored a bit closer. We have London and New York, which are names of cities. So they are being stored a bit closer and away from this subject names. And let's say we send a query regarding Los Angeles. So it is stored somewhere near, or it is vectorized somewhere near to them because they are very similar in nature, and that's basically what a vector database is. Okay. Now we are going to be looking at how we are going to send the data in our vector DB. So basically we are going to be downloading the file from a drive. We are going to be sending it into the Superbase vector store. Again, you see this embeddings OpenAI. This basically is used to embed the data into small chunks into vector format, and then this is to load the data in the vector store. So the first step, as we saw, is storing the document in our database. So we are going to be looking for the Google Drive, and we are going to be looking for the download file option. Okay. Here we need to connect our system with the Google Drive. I've already done it, but let me just quickly show you how to do it. Going to go to create credentials. Here we have Open Docs. We'll go to that, right? And we'll go to a Google Cloud account, which it talks about. So let me go to the Google Cloud. I'll go to the console. And then I'm going to be talking about APIs and services. I'm going to talk to OAuth consent stream. Here we are going to be looking at clients, right? And here we are going to create a new client. And from there, once you create a client, you can create the client ID and the client secret from here. So if I just show you very quickly what this looks like, I have my client ID and my client secret here. I can just copy it, both of these things, paste it back here, and then save it. Then we are going to be looking at the resource file. We are going to do download, which is already set, and then we are going to look at the Sony Home Theater user guide. So let me just quickly search for it, and here it is. And we can just click on execute step, and we can see if this happens perfectly or not. And see, as we see, the output is done, node executed successfully, and we have our file that is needed. Now the next step we are going to be doing is loading into the vector store. So what we are going to do is look into Superbase. We are going to do Superbase vector store, and we are going to add documents to vector store. Now again, you need to set up your credentials, right? We already have we have two fields here, host and service role secret. I already have an account. You might need to create it, and I'll go into my project. Okay. Now from here, I'm going into project settings. Then I'm going to go into data API, and here this is the project URL. I'm going to be copying here, and then come back and paste it here. And similarly, I'll go into API keys. I'll reveal the key, copy it, come back, paste it here, and there you go. We have a Superbase credentials connected. We are going to insert documents. So we need to create a table where we need to store this data. So again, we are going to go into the documents for this, right? And we are going to go into quick start for setting up your vector store. Here we can see the first code. It is basically the SQL code. We can just copy it directly. Go into it, our Superbase key, and then go into SQL editor, and then here we can just paste it. I've already pasted it here, and then coming back to NA10, we will choose documents here. I'll keep the embedding batch size as it is. Okay. Now we are going to be adding an embeddings model. So which model we are going to use is OpenAI. We are going to again connect to our OpenAI account. Okay. So again, we are going to create new credential, open the documents for the same, and then we are going to go to the OpenAI's page from here. I'm going to be signing in, right? And then on this, I'm going to come to projects and manage project. I'm going to come to API keys. I'm going to create a new secret key. I'll just put a name here. Okay, test, let's say demo, to use the default project, and I'm going to create a secret key. And then I have my key here that I can copy and paste, but I don't need it, so I'm going to be deleting this key, right? And I'm going to come here, post the API key, and save it. Then I'm going to using text embeddings 3 small. That is fine. That's a standard one. Next, we want to add a data loader. How to load the documents? I think default data loader is fine for this case. The type of data, we need to change it to binary, because we can see here towards the left side, JSON, it is empty. It's a binary document, which is what we have loaded. So type of data will be binary. We want to load all input data, and the data format, let it automatically detect. Text splitting will keep it simple. And that's how we are going to load our data. And our pipeline is form. So let me just execute the workflow to see how it works. It's downloading the file, putting into the Superbase vector store. It is loading the document and chunking it basis the size, basis the 200 embeddings that we gave. And as we can see here, 98 items, which basically shows that it split the document into 98 items. Now we have the data about the Sony Home Theater user guide in our vector store. Now what we need to do next is basically build a RAG system. Okay. Now I'm going to be starting with a chat trigger, because we are going to be using a chat trigger here, right? We are going to add an AI agent here, and we're going to leave it as it is. Chat model, I'm going to be using OpenAI. You can use any which one that you feel comfortable with. Again, the same OpenAI credentials can be used. The model we are going to be using 4.1 mini. I think that's a standard one that I use for almost all my use cases. But yes, you can refine it if you want to change anything. Then we are going to give it the vector store so that it can call it back. So we are going to again go into Superbase vector store, and as you can see, it has already said retrieve documents as tools for an AI agent, right? In the description, I'm going to say call this tool to retrieve data for retrieve information about Sony home theater. What is the table name? We are again going to be choosing documents that we earlier created here, and limit I'm going to leave it at 4 for now. Okay, again it has an embeddings, so we'll again add OpenAI. We'll use the same account, text embeddings 3 small. That is important because when we're loading the document, we use the text embedding 3 small, so you want to make sure it matches. Okay, now our AI agent is ready. We can just chat with it. So let's say how to connect the home theater system with my mobile device. As you can see, it's thinking about it, then it is retrieving the data from the vector store, then it is again talking with its brain, which is OpenAI LLM, and then it's going to give us our output. To connect your Sony home theater system with your mobile device for Bluetooth, follow these steps. Put the home theater in pairing mode. On your device, search for available devices. Then go to once the connection is established, BT will appear. So on, step 4, 5, 6, and so on. Now it doesn't have any memory, so if we ask it further questions on that, it won't remember. And we want to store the conversations we are having with our RAG agent. So what we are going to do is give it a memory. We are going to give it Postgres memory. Why? Because we can then store all the chat history that we have had and then look at it later on to identify which are the common queries. We are going to first connect it again, and again we are going to go to Superbase. We are going to click on connect, and then we are going to come to transaction pooler. We are going to copy the host name from here. We are going to paste it here. Database, I'm going to leave Postgres because that's what it is mentioned here. User, I'm going to copy and paste it here. Password is the one that you use to create the project. Then port, again I'm going to change because it's not the one that it is there, 6543. So I'm going to paste it and then save it, right? Now once we have the Postgres account, we can then look at the different other parameters. So table name and it in chat histories, I'm going to leave it as it is. You can change it if you want. And context window length is 5. So it basically means how many conversations it is going to remember. So we are okay with 5 conversations to be remembered. So I'm going to leave it at that. Okay. I'm going to save it. Now I'm going to ask it how many devices can I pair with my home theater system. So it's again looking at its memory, but it didn't find anything. So it again looked at the Superbase vector store, and you can see here the executions. When we sent the chat message, it went to the AI agent, it checked in the memory, it didn't find anything, then it went ahead and checked with the LLM. LLM instructed it to go to the Superbase vector store. Then it again, once it got the output, it talked to the LLM to phrase it, and then it stored it in the Postgres. And here we can see number of devices depends on the standard type of device. According to the standard, recording devices up to 3, playback device up to 3, and so on and so on. Now if I ask how many tuner related devices can I connect, it's not going to go into the Superbase vector store because it already had that. We can see it looked into its memory, then it talked to the LLM brain which it has, and then it again stored it here. And now if I have to come back here and show you where my different databases are, we have a documents and we have an in chat history. So if I open this, you can see the session IDs that are here. That's how you can create a RAG AI agent, and obviously you can make modifications. Let's say if you don't want to have it as an internal tool, you can also convert it into a chatbot which the customers can directly chat with. Obviously it will need some modifications and a chatbot UI to build with it. And yes, that's how you can do it. You can also do other modification as to delete the documents and update the documents when it is updated to scale the knowledge base. I haven't covered that in this video, but let me know if you want me to cover it. And yeah, that's all from me. Have a good day.